Thank you, Filippo. And now, let's pick up the pace again and let's move on to the next presentation. Let's welcome to talk about production of digital twin solutions in Vilnius city, experience, challenges, and the future. Let's welcome Dominykas Petronis.
Well, hello everybody. I'm really happy to have a chance to present our experience as Vilnius city in a digital twin topic. I will share basically how we understand and approach this concept, also show you the digital twin solutions we already are creating in the Vilnius city. But just for general introduction, what is ID Vilnius, the company which I'm representing? Thank you. So it is a municipalities company which was established in 1996. The original goal of the company was to basically help with innovation of cities development. And right now, after like 27 years, we have almost 150 employees. And the mission of the company is really close to the original one. Basically, it is to help to create a balanced, innovative city by providing various services to municipality and the public. And if you're talking about these services which we provide, they can be put like into four main categories. One is like spatial planning and urban planning. It is more focused on basically designing public spaces, green spaces in the city, also creating spatial planning documents, for example, general plan of the city, also like architectural guidelines. There's another side of the company which I'm representing. It is data management and smart solutions. Basically, it's the upkeep of GIS infrastructure in a municipality. Also, by providing these two services, we are supposed to act as this innovation hub for Vilnius city and provide like innovative solutions for better management and upkeep of the city. And if we're talking about like innovative solutions, well, as you probably know, the term itself, the digital twin, has really like gained popularity in the last few years. The Vilnius municipality is no exception. There's a lot of interest in this topic, but at least how we see it right now, that, well, at least in Vilnius, there is no really like clear understanding and definitive answer to like fundamental questions of what digital twin even is, what characteristics define the digital twin, also what steps should be taken in creating solutions in this like digital twin topic. And like in order to answer these fundamental questions together with the municipality, we basically are starting to create guidelines for the basic production of digital twin solutions in Vilnius city. We just started these guidelines, just as you've seen like an example of Italian presentation. We're also trying to make an inventory of existing solutions in Vilnius produced by us as ID Vilnius and produced by other municipalities companies. But at the start of these guidelines, we really try to answer what is a digital twin for us. And even though we just started, we can already define it a little bit more clearly. So for Vilnius cities, definition of a digital twin is quite simple. It is a virtual representation of physical or non-physical objects in its relationships, like in virtual environment. And for a system to actually like classify as a digital twin, it's not just enough to have a 3D model or something. We determined that it needs to have like 5 criteria. First one being, it needs to be based on like accurate real-life measurements, so it would be possible to actually simulate different conditions. The second criteria is that it needs to be based on constantly updated data and like real-time data. The third criteria is that it needs to follow like best practices of data security and protection. Fourth criteria is that the digital twin needs to integrate easily with different systems in a city and also be able to integrate different data types in one environment. And lastly, the digital twin, the environment itself, it needs to be easy to use and user-friendly, so the municipality specialists could actually use this digital twin for like day-to-day work. Also, by creating these guidelines, we are trying to create like a roadmap for the production of these digital twins and what path should we take. We are evaluating different like outlooks on this topic. In Vilnius municipality, at least, there's this popular understanding of digital twin that the digital twin should encompass all sorts of different systems in one place. For example, a digital twin of the city should have like asset management of buildings, streets, I don't know, like weather conditions in one place. And it would be supposed to act for a lot of functionality in Vilnius, but by providing these guidelines, we're assessing the like possible risks and taking this vision a little bit down, because, well, if you try to create these enormous digital twin like solutions, it would probably cost a lot. The just technical complexity is like really huge. Also, there's lack of standardization. The bureaucratic problems would be quite big in our scope. So right now, at least in Vilnius city, if you're leaving like this theoretical part behind, we're thinking about a digital twin more of a like sum of solutions we create for Vilnius city and like for different functionality. We're not creating one big system, but taking like solutions to solve mainly like single problems. At this time, mainly it is infrastructure. So if we're leaving this more theoretical part behind, I just want to highlight some of the more interesting solutions we are creating for Vilnius municipality to solve a variety of the problems. I want to like show you what different data types we use to create all sorts of different solutions, and maybe I will hope that it will be just interesting to see the actual products which we are developing ourselves. So I hope that you will be able to gather some new ideas at least. We can just begin with the quite old solution by now, but the data is constantly updated. It is a 3D Vilnius portal, which is basically a public website which contains a variety of 3D information, like 3D mesh of the city, 3D model of the city. It has not only like current buildings models, but buildings which are being created right now, being built or just designed right now. It also has other 3D information like technical plans in 3D, general plan of the city in 3D as well. There's somewhat integrated BIM models, but it's not really that widespread. So we are also creating similar solutions to two Ukrainian cities right now, Bucha and Borodenka, which we're quite proud of to start this project. But if you're talking about like a digital twin context, this portal could be like a basis for creating bigger digital twin solutions. It could be like an environment where we put other information on top of. But let's switch to a little bit different topic. Well, in Vilnius city, the mobility is quite important as well, as you just seen in the last presentation. But we are taking a little bit of a different approach. Right now, we are just developing an application which is called Vilnius City Mobility Map. It is based on mobile operator data, which is provided by us for us. We use this mobile operator data to basically calculate the intensity of use of the streets in Vilnius, put all of this information into the application, which shows the basically traffic of the last day. You can analyze basically problematic areas in the city. Also, it is just used for day-to-day work for the specialists in the municipality. Although we're still developing this application, the main challenge is using the mobile data, the data from mobile operators. At first, we used to get the data processed, but once we checked the information, it find out that data quality is not that great. There are some like problems with it. So if anybody is using mobile operator data, so just please let us know, because any help would be really appreciated. On the same topic, we have another product which is called Vilnius GSM. This time it is an application which is used for assessing the street surface condition of the streets. So how this works is that once annually, since 2022, our partners scan the streets using LiDAR scanners. They use this little bus which is shown on the picture, and they gather all sorts of information about like the cracks in asphalt, unevenness of the road, other pavement conditions. Once they gather this information, then we also integrate other data like intensity of use of the streets, the public services around them, public transport intensity of those streets. And what it is used for, in the end of the day, it's basically to create a list of streets which says which streets are the worst in Vilnius and which streets are in a little bit better condition. So the specialists in the municipality basically use this list at the end of the year to plan the maintenance work of the next year. So that's why we scan once a year, basically. It's more of the tool for planning the maintenance of Vilnius streets. Even staying on the same topic of the street infrastructure, we have other solutions. For example, informational system for traffic control measures, or simply put, it is a system for upkeep of street signs in Vilnius. At its core of this application is its database. It contains more than 60,000 street signs in a city, vertical street signs. Also, there's around 1,500 kilometers of horizontal street signs. And this application is basically used for any tasks which involve street signs in the city, from planning of new intersections, for example, to working as this management environment for communication between the municipality people and the contractors. If you need to like change a street sign or anything relating this infrastructure, everything needs to be done through this application. And the last, basically, product in this street infrastructure aspect is the inventory of the trolleybus contact network, which was finished 2 years ago by us right now. So in Vilnius city, there is like no trams or subways. The main public transport is buses and trolleybus contact network. But until recently, like the company who was responsible for the maintenance of this network didn't have any like digital information about it. So using 360 panoramic photos and just like paper formats, we digitize this network, and now it's used for like everyday maintenance and upkeep of this network. So we can probably move away from like street infrastructure and go about like utility networks. We have one project which we actually do call a digital twin. It is called a digital twin of Vilnius city stormwater drainage network. So if you start from the beginning, once we started with this project, we really wanted to modernize the existing data of the stormwater drainage network. We did have like lines of the pipes in GIS formats, also like point data about the wells, but we really needed to modernize it. And how we approached it is that we basically, our partners used, once again, LiDAR scanners. You can see a little card here of their own design, which was used to scan wells in a city. So in a period of 7 months, they scanned around 12,000 of these wells of this network. Also, they surveyed around 500 kilometers of pipes in the city, which with a bigger diameter than 300 millimeters. So they gathered the point cloud information. All of this data traveled to us at ID Vilnius, and we used it to create basically a city-sized 3D model of the network. But even probably more importantly than the model itself was the calculation of the attributes of the network. For example, what is the volume or diameter of the well itself? We checked if the diameter of the pipes are accurate compared to the previous data we have and so on. This was really important to validate the information, because this validated information is now used for basically the simulation of drainage network capabilities. For example, we can now simulate different weather conditions, participation amount, and see if the existing network can manage these like potential loads. If the municipality is planning the new section of the network, you can simulate it and see if it would handle these potential like water loads, or it should be this network should be created a little bit bigger. So because it is based on this accurate real measurements, we do call this a digital twin, but if you're being like completely honest, it probably lacks a little bit of like real-time data. Also, there's a problematic aspect of keeping this 3D model up to date, but at least we're trying to come up with better solutions for keeping this data relevant. Now moving toward all different topic compared to the like previous infrastructure objects. At ID Vilnius, we utilize a lot of drone data. In-house, we have a drone operator center. There's 4 people working every day only with drones, basically. We have 4 autonomous called drone boxes, where drones can fly remotely, come to this box, they change the battery inside it there, and the drone flies once again. So it's used in quite a few projects right now. One of them being like waste containers inspection. In Vilnius city, we have 250 of these waste collection sites, which are classed as like problematic. And how we use drones to inspect this is that we fly twice a day to these drone sites, and they take pictures of the collection sites, and we use AI models, which were at this time created by us in-house, to basically identify if there's any rubbish or waste left outside of containers. We somewhat can identify the type of rubbish. Also, we see if the lids of the containers are open, if there's a sandbox left at the collection site. And once this information is processed, it travels to like this dashboard, and people in a municipality who are responsible in this field basically plan the maintenance, plan the waste collection a little bit better, because they understand what is the like current problem at this waste collection site. Other project which we use drones as well is used for roof condition inspection. So basically we use drone images to create like 3D surface elevation models of buildings' rooftops. Also we just take regular pictures, and AI models try to at least identify the defects on the roof. Right now we are quite accurately can determine if there's a plant life on top of the building, if there's water puddles, but we're struggling a little bit with identifying the amount of rust, because there's a lot of variables and it's quite difficult to identify rust using just like pictures. But nevertheless, the municipality still uses this application quite a lot, but it's mainly used for just fast checking of the problems, just primary check, and it's used for a big amount of buildings. Right now we have 450 of these models, and if there's like problematic areas, we usually, then the person goes in field conditions and actually checks it. But for primary like inspection, we think that it's quite useful because it's way faster and it can be done cheaper compared to field conditions. Moving on, still staying on the topic of drones, I want to just mention a couple of solutions, but they're at a completely like experimental stage. We're still researching it. It may become like actual project for the municipality in the future, but we're just trying right now. One idea is to identify heat islands in a city. So basically our drones are connected with thermal imaging cameras. They can take the pictures of the ground and basically calculate their temperature. And we are thinking of basically identifying the most problematic areas in Vilnius city for heat island formation. And once identify these heat islands, we want to basically simulate what would happen to those heat islands if we plant a new tree, if we change the pavement type, and so on. So this is one idea. Another one is for, basically it's called the grass plot mowing status, but to put it more simply, we want to inspect if the green spaces in Vilnius is maintained properly as it's supposed to be, if it's not overgrown, if the length of the grass is as it's supposed to be, because maintaining these green spaces is quite an important part of Vilnius municipality's strategy, at least at the current level. So we're developing a solution for that. It might seem a little strange, but while you fly these drones, you can just take the pictures on its way for other projects, so it probably wouldn't be that expensive to check it this way, but we do have some technical difficulties just for evaluating if the plot of the grasslands is maintained properly, but we're still trying to develop the solution. Now, other types of products we have. We talked about drones and more about infrastructure. We have two solutions which are based all about real-time data and capturing information from sensors, basically Internet of Things products. So one of them being lungs of the city. You all already seen a presentation about the air quality. So this is our air quality map, although it's way more simpler in context. It just shows the current level of air pollution in the city based on different criteria. Also, it has information about amount of air pollen which is in the air. We have 26 sensors throughout the city which capture this information. It is done every 5 minutes, so this application provides real-time information, and the main goal of it is to basically give information to the public. If there pollutants are above a standard, there are health recommendations, and also if there's a huge amount of pollen in the air, it could be problematic for people who have allergies. So this is the main use of this application. The second application, which also relies on real-time data, is maintenance vehicle tracking informational system. So the cars who are responsible in Vilnius for cleaning the streets, washing the streets, cleaning the snow, are equipped with GPS sensors, and basically we track their activity levels. We see the paths they take throughout the day. We calculate the area which they cleaned during the day. Everything is shown basically on just simple dashboards, and the people in the municipality can basically plan their work more efficiently. Now we talked about a lot of more infrastructure and upkeep of the city, but at ID Vilnius we provide even a little bit different solutions. For example, in the field of history and cultural heritage, for the current government in Vilnius, this topic is really important. So we have a few quite interesting public websites. One of them is Vilnius DNA. It's just this historical geographical hub of Vilnius city. It integrates a lot of different historical information. For example, historical city plans and maps, also historical photographs, historical street names and their network, which was digitized from these historical maps, sculptures, plaques, and much more. It's really just interesting to look around, to understand Vilnius a little bit more. You can learn about Vilnius a lot through this application. And we think of it as just this digital Wikipedia, which is only for Vilnius. And another product which is in the last stages of development, it is a system for Vilnius cultural heritage buildings, especially wooden buildings. So it's just basically a public website. There's a map with information about each and every important heritage building. You can just read about the information. But a little bit more interesting side of it is that we have 3D photogrammetric models of those buildings. They are really, really detailed, but this application was supposed to actually come out a few months ago, but we are really struggling with how fast these models are loading. And that's mainly the biggest problem of this application. So we're still trying to find a better way to basically show them in the application, which works basically just in a browser. Also, this application has not only the models of buildings themselves, but even the smaller components of the buildings, which cultural heritage registry deems as important. For example, windows, door handles, doors itself. If it's important, they have a 3D model. Well, going towards the end of my presentation, we have a little bit different side of the inventory. We inventorize a lot of infrastructure, but also other objects. For example, we have a digital registry of Vilnius cemeteries. At the start of this registry, digital registry, how the cemeteries were maintained. Basically, they have these paper journals, and everything, all the information was not digitized. So throughout a couple of years, actually, we digitized these cemeteries, and now it is a public website where anybody can basically browse through the information of this database, search for deceased people by name, see where they are buried, and so on. Also, quite importantly, this application provides services for the municipality for issuing like permits for burials. So there's no need to like go physically now into the municipality to ask for a permit for issuing for the permits of these burials. Everything is done through the system. So since probably last couple of years, more than 12,000 of these issues were permitted, of these permits were issued through this system. And quite interestingly, I even find it quite funny that this registry is the most visited website, public website in Vilnius. So there's like these national holidays, at least in Lithuania. I don't know how it works in other countries, but for basically one day is called the Day of the Spirits. Basically, it's a national holiday, and you're supposed to go to the cemetery and like pay respects to the deceased people. So the use of this application through those days just skyrockets. Our fear is that people forget where they're like people there and their like family is buried. So they use this system to remember where they are, basically in the cemetery. And switching the topic, last two applications, I think I still have a little bit of time, are about the maintenance and the upkeep of the city. One application is called Honeycomb. It is based on information which is gathered by mobile applications. So how this works is that elders in their prescribed elderships register the problems of the city, for example, unclean stairs, broken playgrounds, or something like this. All of this information comes to the dashboard and it's registered. On the other side, there's a person in municipality who works with this application, and he assigns a contractor who is supposed to basically fix the problem itself. Also, the required documentation is also automatically created. So we cut out the middleman. There's no need to send emails or search for someone who's responsible. All the like this maintenance of the city can be used in this application. And the last product, which we just released last month, and we're quite happy about, it's called Vilnius Deck. It's an application which is used for communicating for municipality, utility companies, and other municipalities companies to plan the maintenance work. Because quite a big problem in Vilnius is that the lack of communication between different companies. And what I mean by that, it's, let's imagine the situation that a company who's responsible for street infrastructure repaves a new street, and the other like utility company has planned to change the pipes underneath there like 2 months in advance. So they dug up this new street, laid a pipe there, and we need to repave the street once again, basically spending more money, creating more inconvenience for the people. So this application is meant to basically try to solve these problems, because everybody in municipality can see each other's maintenance plans. They can communicate through this system. We also provide like various tools for them to see if their like maintenance plans are in the same time period and same space in the city, and so on. So these were the products I just really wanted to highlight. Maybe I strayed away a little bit for a digital twin topic, but we still can think of these solutions I presented as the building blocks, which in the end of the day create a vision of a digital twin in a city. But just to sum up, we are creating like guidelines for Vilnius City digital twin production. We're determining what it is actually. We're creating the guidelines in which the whole of the municipality would understand what a digital twin is a little bit better. Also, we're determining the roadmap of digital twin implementation, deciding if we should go in this integral way, creating big digital twin solutions, or the digital twin solution should be separated by function. And I hope that in later years in Vilnius city, we will be able to answer this question more clearly, and basically we'll have more understanding about like a digital twin topic as a whole. So I guess that's it. Really thank you for your attention. If you just have any questions, please write me an email, because my boss will be very happy. He said I will do a good job. There's a lot of interest. So thank you very much.